Okay guys, we're going to be continuing to look at finding the inverse. And right now we're going to focus on the graphs of inverses. So here are the steps that we're going to take. We're going to plot the points from table 1. So let's go ahead and do that. Okay, so I plotted the points. Hopefully you're pausing the video to plot the points as well. So what we have here, I'm going to go ahead and connect my dots. Now this is a new function that we have not studied yet. This is an exponential function. If something grows exponentially, it's growing rapidly. As you can see, it starts down here real small, and actually it goes right along the x-axis. This is an exponential function. Okay, the parent is y equals, and there's different parents. We're just going to use base 2, but what's important here is where the x is located. It's located in the exponent. This is an exponential function. So, but that's not the purpose of this video. We're looking at finding the inverse of a function. So, B. Switch the x and y coordinates. So let's do that. I'm going to pause the video. Okay, so we switch the x and the y just like we do when we find the inverse of an equation. We switch the x and the y. So this table represents the inverse points of the original function. So let's go ahead and plot these points. Okay, so we see the points here. Now I'm going to go ahead and connect them. Okay, so this represents the inverse of this. Okay, it says draw the line y equals x on the graph. Well, that's easy. The y-intercept is 0. The slope is 1, so over 1, up 1, over 1, up 1. This line here is called the line of symmetry. And see if I can get this to line up, because sometimes they don't line up very well because of the way it's printed. The way the copy machine might change the scale a little bit. And you know what? We need to do that different, because this line of symmetry should be dashed because it's not part of the graph, but it splits the two functions symmetrically over the origin. See, it goes through the origin. Okay, so y equals x. So if I fold this in half, this graph, if you flip it over, if you reflect it over y equals x, it will land right on top of this one. And so when you're looking at a graph, think, if I flip this over, will it land on itself? And if it does, then they're inverses of each other. Okay? So let's look at example 2. We're going to need to plot these points. So I'm going to pause it and do that. Okay, so what do you notice? What type of function do we have here? That's right, we have a linear function. Linear function. By the way, just so you know, the inverse of an exponential function, this one here, creates a different type of function, and this function over here is a logarithmic, which we'll learn more about later. But I'd like to introduce you to it since we are drawing it here. And the parent, again, if this was the exponential, we would say y equals log, the base is 2 of x. So notice the base is 2, the base is 2. Okay, let's go ahead Now, looking at this page, we've already done this, but I don't feel like we have quite mastered this. I think this was probably the most missed part on the test. And so, I mean, this is some important information we just talked about. I'd like you to practice doing the inverse and go ahead and find the inverse of these three problems for tomorrow. And let's take a look at this one. It says write the equation of the inverse and then graph the following relation and its inverse on the same set of axes. Okay, so the word relation just means the comparison of two values. Okay, so for example, when we have a table, there's a relationship between these numbers. Okay, and it doesn't have to be a function either. If you have a table, you have a relation. Some tables are relations and some of those relations are functions, but not all of them. Not all of them. Okay, so let's take a look at this. Let's graph it. Plus 4, 1, 2, 3, 4. Rise over run, 2 up, 1 over. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Down 2, left 1. Down 2, left 1. And graphing this up here. Okay. Now I'm going to go ahead and quickly find the inverse, showing all the steps, not taking any shortcuts here. Okay, so there's our inverse. So here's our y-intercept, -2. Rise over run, up 1 over 2. Okay. Let's graph it. Now, let's go ahead and draw in our line of symmetry. That's going to be y equals x. And I want you to notice something. So there's your line of symmetry. And of course, I keep forgetting to make it dashed. But pretend it is. So, is the relation in a function? Is the relation a function? How about that? Yes, both of these, the inverse of a linear is a linear function. And lines, unless they're vertical, all lines are functions. So yes. Is the inverse a function? Yes. Easy peasy. Okay, I would like you to try number 7. See what else. It says there is a way to tell if the inverse is a function by looking at the graph of the relation. It is called the horizontal line test. Okay? Without graphing the inverse, determine if the inverse of the following relation is a function. So we haven't done cubic functions, so let's just go ahead and do the quadratic parent function. Okay? So, input 0. 0 squared, output 0. Input 1. 1 squared, output 1. Input 2. 2 squared, output 4. Okay, let's do the other side. Input -1, -1 squared, 1. Input -2, -2 squared, 4. Good enough. Oopsie. Who should I give a shout out for today? How about Miss Ashley? Miss Ashley, I hope you're watching my video. I hope you're watching my video, Ashley. Okay, so now look what it says. There is a way to tell if the inverse is a function. So we're not going to graph the inverse. We're not going to find the inverse. We're going to be able to tell just by doing what's called the horizontal line test. So if you draw a horizontal line through the graph and it touches in more than one place, okay, then the inverse is not a function. So we draw a horizontal line on the graph so I wrote it out. So once more, draw a horizontal line on the graph, so there it is, and if it touches the graph in more than one place, then the inverse is not a function. Very easy to figure out. Look back at the first one. See, here's my original function. Now if I draw a horizontal line anywhere on this graph, does it ever touch in more than one place? Now you might think so here, but it doesn't. It doesn't. And the answer is no. And so that means that the inverse is a function. And remember, you can tell by doing a vertical line test to see if it is a function or not. Remember, you can only touch in one place, anywhere on the graph. Okay, I think that's it. Hope you guys are having a good night. I'll see you tomorrow.